Okay, I received this video from one of you guys, posted that you really need to know how you can analyze and solve this question under pyramid and frustums. So the question reads, the diagram below is a pyramid with a rectangular base measuring 12 by 9 centimeters and its frustum, as we can see below here. We can see our frustum, right? We can see our pyramid. Okay, the first diagram here, this is our pyramid. Its base is a rectangular base, that's what it has, measuring 12 centimeters by 9 centimeters, and its height is 45. Now when you look at what we have on the right side, this is a frustum which is created from the pyramid that we have. So we don't know the height of this frustum, right? Okay, so this takes us into the second stage, that is answering now the questions. We have question A, B, C. Now question A reads, given that the height of the pyramid, okay, this pyramid, remember this is a pyramid, this is our frustum. Okay, let's go to the second step where we are going to solve from. So this is what we have right here. Okay, so let me just get this pen here. Okay, so when you look at what we have here in question A, says given that the height of the pyramid is 45 centimeters, calculate its volume. Okay, so we are concentrating on diagram 1, this one right here. Okay, we have put a mark. So this is a pyramid and we want to find the volume of this pyramid. So we don't have it. So to find the volume of the pyramid, we can start by observing what we have. We have 45 centimeters, okay, as the height of this pyramid. You can see that, right, from here up to the bottom. We also have the rectangular base for this pyramid. Now before we go any further, also I want you to remember that this frustum we have, okay, assume it was complete, okay, since it is just part of the pyramid we have, okay, for it has to be completed like that, right? Okay, like that. Good. So if it is completed like that, the okay, let's say the upper part, right, it needs to have its own height, okay, and that height should start from that to up to the top part there, okay, up to the vertex. Okay, so this should be the height of the upper part, right? Good. So we are going to use that in question B. Okay, just take note of that. So we have a pyramid, then we have this frustum which was cut, or which is part of the pyramid, but we should not ignore the upper part. Okay, so this top part which I've just drawn there with a red pen. Okay, you can see that. Okay, all right, good. Now we can proceed now. So what we need to do, we just need to get into solving. We have the volume of a pyramid. So the volume of a pyramid, you just need to insert the formula which you need to remember. So the formula for the volume of a pyramid is given by 1/3 multiplied by base area multiplied by height. Okay, if any of you have questions on why the formula is 1/3, okay, I think just pause the video, one of my videos on scroll up, you find how this formula uses 1/3 and why we use 1/3 in front. Okay, so this is the formula of a pyramid. It's given by 1/3 multiplied by the base area. Okay, you need to calculate the base area of that pyramid you have. So in this case, we are told it has a rectangular base, so we need to calculate the area for this rectangle, okay, which is the base of the pyramid we have. Okay, so that's what we are going to substitute here under base area, and we need to multiply by its height. Of course, the height of this pyramid is 45, so we are just going to substitute. If we do that, we are going to have 1/3. Since our base shape for the pyramid is a rectangular. We know that the area of any rectangle is given by L times B, right? So we are going to substitute the base area of that rectangular base we have is L times B and multiply by the height. Okay, so if we substitute, our length is 12, our breadth is 19, that's 9, okay, as you can see here. So you substitute your length and your breadth, multiply by the height. Okay, the height of the pyramid is 45 centimeters. So you just need to use your calculator and you are going to find your volume to be, that's 1620 centimeters cubic. Okay, so that's the volume of the frustum, which is the complete thing here, right? So take note of that and remember that the frustum here which we have was part of the frustum. Maybe let me just okay, let's do that. Let me just erase this part so that you are able to see clearly how this was before we had put those lines. Okay, like that. So this is how it was, right? Okay, now let's okay, proceed. That is now question B. So we are done with question A. Now question B. Okay, I've removed those lines. You see how they are coming about. We have given that the volume of the frustum of this pyramid is, that's 1140 centimeters cubic, right? Now we need to calculate the perpendicular height of this frustum. So the frustum, it's this diagram, the second one right here. Okay, there. Now remember that this frustum is part of the pyramid, of which we have calculated its volume, and the volume of the pyramid, it's this one right there. Okay, so what this means is that the volume of this frustum, it should be subtracted from the volume of the pyramid that we have calculated, right? Good. Look, the missing part here is the top part, right? Oh God. Okay, the missing part there is simply the top part. Okay, let me just erase this. So the top part is the only part which is missing, meaning that the volume of this pyramid, which we have calculated, which is 1620 centimeters cubic. Okay, if we subtract the volume of this frustum without the top part, the volume that we are going to have will be the volume of this top part. Now I'm including right here, you can see it. Okay, this one, that one, right? So this top part, we need also to find its height. So if we find the height of this top part, okay, let's say this will be the height of the top part. So the height of this top part, if we find it, then we subtract from 45, which is the total height of the pyramid, of which the frustum was gotten from. Then we'll be able to find the height of this frustum from that end to that end. Okay, so look how we are going to strategically do that. So we are going to let V2 be the volume of this frustum that we have been given. Okay, that is 1440 centimeters cubic is the volume of this frustum without the top part, right? And let V1 be the volume of the entire pyramid, okay, which we have calculated. So here what we are going to do is we are going to subtract the volume of this frustum, okay, from the volume of pyramid, of which the frustum is part. So by subtracting, we are remaining with the volume of the top part, of which it will help us to calculate its height. If we calculate the height, we'll be able to calculate now the height of the frustum by subtracting that height, h, from 45. Hope you get the concept. Okay, just pause the video and follow it slowly. You'll be able to understand. Actually, there are many ways we can solve this question, but I thought this will be a simple way to explain it so that you understand. However, you can still get to me through the comment or the email in the description there. Okay, let's proceed. So let's subtract now V1, we subtract V2, that is the volume of the entire pyramid minus the volume of the frustum, which is part and parcel of that volume of the entire pyramid. Okay, so if we subtract, we are getting 480 centimeters cubic. So this 480 centimeters cubic we have calculated is the volume of the top part. So it's like we have a small pyramid, okay, on top here, okay, which has also a rectangular base like this, right? Good. Like this one. Okay, so this is what we have here, okay, on top, and it has the measurements, that's 8 centimeters by 6 centimeters, but its height is unknown, right? So the height of this small pyramid right here is unknown, and that's what we are trying to find. So since we have the volume of this small pyramid, the top, what we are going to do is we are going to apply the volume. So that volume we have calculated will be V3. So V3 is the volume of the top pyramid, okay, which has the base, the rectangular base 8 by 6 centimeters. So if we apply the formula, we are going to substitute. Remember, the bottom or the rectangular base for this small pyramid, the top part is measuring 8 by 6 centimeters. So we have L times B and multiply by its height. So we have V3, which is the volume, which is 480, is equal to 1 over 3 times 8 times 6. We don't have the height, remember. This is the reason why we have used the V3, which we have calculated, because we want to find the height of the top part, okay, the top small frustum there, the top small pyramid there, okay, whose volume is 480. Hope we are following. So the height you can calculate. So when you do that, you are going to find the height to be nothing but 30 centimeters. Okay, so the height of this top part, right? The height of this top part, okay, look at my explanation there. We have found that this is 30 centimeters, right? And the entire height of the complete pyramid is given to be 45, right? It's given to be 45. So we have 45 centimeters. 45 centimeters is the height for the pyramid from which the frustum here was taken, right? So for us to find this height now of the frustum, which we can call maybe x2, we need to subtract 45 minus 30. It will give us the height that we need, that is the height of the frustum, which we have been asked to calculate right there. So what we are going to do here is simply, hence the height of the frustum is equal to 45 minus 30 centimeters. This will give you 15 centimeters. So the height for the frustum, that is from this part to this part, is simply 15 centimeters. So 15 centimeters plus 30 centimeters here, it will give you back here 45 centimeters. All right, and let's go to the last question. C says, if the frustum above is full of water, which is to be drained using a hose pipe of inner radius 2.5 centimeters at an estimated speed of 0.5 meters per second, calculate the flow rate of the water being drained. Okay, so there again we just need to apply the formula. We know that our flow rate is given by cross-sectional area multiplied by velocity or the speed. Okay, so when you substitute with the data you have, remember that the cross-section area, the question is talking about a pipe. Okay, this pipe, the cross-section area of this pipe is circular, right? That's why we have used the volume for the formula for the area of the circle, because the pipe through which the water is being drained at v speed, which is 2.5 centimeters, the speed at the speed of 0.5 meters per second, is circular. Hence the cross-section area we have used the area of a circle, then we multiply by the speed at which that water is being drained. So the flow rate is going to be, when you substitute pi is 3.142 multiplied by the radius, which is 2.5, now that has to be squared, multiplied by 0.5, which is the speed at which water is being drained. So when you use your calculator there, you do a computation, you are going to find the flow rate to be 9.82 centimeters cubic per second. Now it is very easy to understand when you convert the answer you have in liters. So you can convert your answer from centimeters cubic per second to liters per second, since we know that 1 liter is equal to 1000 centimeters cubic, right? So the flow rate in liters is going to be 0.00982 liters per second. So this is how you can calculate this kind of question. Again, thank you so much for watching this video. Please remember to subscribe to this YouTube channel for your support. Thank you so much for that. You've been watching my YouTube videos. Remember also to share and subscribe. Thank you so much.